titration to volumetric analysis. Volumetric analysis is any method in quantitative chemical analysis in which the amount of substance is determined by the measurement of the volume that the substance occupies. It is commonly used to determine the unknown concentration of a known reactant. What is titration? Titration is a process in which a standard reagent of a known concentration titrant is added to analyte solution until the reaction between the analyte and reagent is judged to be complete. The type of titration used in this study is acid-base titration, which is useful when the product has to have a precise pH range. Next, calcium carbonate in eggshell. A good quality eggshell will contain on average 2.2 gram of calcium carbonate. Approximately 94% of a dry eggshell is calcium carbonate and has a typical mass of 5.5 gram. In the case of a brown versus white eggs, a definitive difference in calcium carbonate amount may be hard to uncover. A brown eggshells increase tendency to break when compared to white, which is attributed to this thinning out of calcium during deposition. So how titration is used to determine calcium carbonate in eggshell? By using back titration, a titration where the concentration of calcium carbonate is determined by reacting it with known amount of excess reagent. The remaining excess reagent is then titrated with another second reagent. There are two equations for back titration, which are: the first one is 2 mole of HCl react with CaCO3 producing CaCl2 and CO2. The second one is HCl react with NaOH producing H2O and NaCl.
In this part, I will be explaining about the theory for determination of calcium carbonate in eggshells using back titrations. The major component of eggshell is calcium carbonate. This analysis will be done volumetrically by using a characteristic reaction of carbonate compound, namely their reaction with acid. In this theoretical part, the study was an acid-base titration. The use of back titration is to find the calcium carbonate percentage of eggshells of hens and ducks. Calcium carbonate, which also called as a limestone, is very insoluble in pure water, but will readily dissolve in acid according to the reaction. This reaction cannot be used directly to titrate the calcium carbonate because it is very slow when the reaction is close to the end point. Instead, the determination is achieved by adding an excess of acid to dissolve all of calcium carbonate and then titrating the remaining hydronium ion with sodium hydroxide solution to determine the amount of acid which has not reacted with the calcium carbonate. The difference between amount of the hydrochloric acid initially added and the amount left over after the reaction is equal to the amount used by calcium carbonate. From this, the amount of calcium carbonate used in this sample can be calculated. In normal cases, eggshell contain 95% calcium carbonate, 3% phosphorus, 3% magnesium, and traces of sodium, zinc, manganese, ferrum, and copper. A good quality eggshell will contain on average 2.2 grams of calcium in the form of calcium carbonate.
In this methodology section, the apparatus and chemicals used for this experiment were carefully selected, ensuring they align with the study's objective and are detailed to provide clarity for replication and validation purposes, which are burette, pipette, conical flask, mortar and pestle, hot plate, analytical balance, retort stand, watt tiles, chicken egg and duck egg, 0.2 molar of hydrochloric acid, 0.1 molar of sodium hydroxide, phenolphthalein indicator and methyl orange indicator. The procedure for standardization of the sodium hydroxide solution, we begin with fill in the burette with the sodium hydroxide solution. Then pipette 20 ml of the standard potassium hydrogen phthalate solution into a conical flask. After that, add 2 drops of phenolphthalein indicator. Titrate the standard potassium hydrogen phthalate with the sodium hydroxide solution. Repeat the titration 3 more times. Lastly, calculate the concentration of the sodium hydroxide solution. Next, the procedure of standardization of the hydrochloric acid solution begin with pipette 10 ml of the hydrochloric acid solution into a conical flask and add 2 drops of phenolphthalein indicator. Then, titrate the hydrochloric acid with the sodium hydroxide solution from the burette. Repeat the titration for 3 more times. Finally, calculate the concentration of the hydrochloric acid solution. The last part of this procedure is analysis of the eggshell. First of all, obtain some dry egg, the inner membrane being removed. Grind the eggshell in a mortar and pestle into small particles. Pipette 20 ml of the standard hydrochloric acid solution into the conical flask that contain the eggshell. Wait for about 2 to 3 minutes. After that, heat the reaction mixture to boil. Cool it down and add 2 drops of methyl orange indicator. Then, titrate the mixture with sodium hydroxide until the color changes to yellow. Repeat step 2 to 5 and calculate the percentage of calcium carbonate in the eggshell.
After the experiment has been conducted, we can obtain the result for titration of eggshells dissolved in excess hydrochloric acid against sodium hydroxide in brown egg. Trial titration is performed to approximately determine the endpoint of the titration. In titration, a permanent chemical change can be observed after a certain amount of the titrate is added. The endpoint is the part of the titration where a visible chemical change occurs, such as color changes and precipitate formation. We perform trial titrations to avoid using excess reagents and have high precision and accuracy in the results. After the titration has been repeated 3 times, we can obtain the average volume of sodium hydroxide in brown eggshells, which is 16.10 cm per cube.
After the titration has been repeated 3 times, we can obtain the average volume of sodium hydroxide in white eggshells, which is 70.846 cm cubic.
Next, I will continue to explain about how we calculate the back titration in a brown and a white eggshell. From this page, which is the brown egg calculation, we can see that the first step is we need to calculate the number of mole hydrochloric acid that added to the mixture. 0.20275 is the molarity of the hydrochloric acid. Multiplied with the 25 ml, we will get a 5.1875 multiplied with 10 power of negative 3 mole as the answer. Second step is consider a second equation to find a ratio of the number of mole of hydrochloric acid left. 0.001188 is the number of the molarity of sodium hydroxide multiplied with the average volume of sodium hydroxide that we obtained in the experiment, which is 0.0161 liter. The answer is 1.62913 multiplied with 10 power of negative 3 mole. The third step is to find the number of mole of hydrochloric acid created. This can be obtained by the subtract the number of mole hydrochloric acid added to the mixture minus the number of mole of hydrochloric acid left, and we will get the 3.55837 multiplied with 10 negative 3 mole. Fourth step is consider a first equation to find a ratio number of mole hydrochloric acid and the number of mole calcium carbonate. It is 1:2, so the number of mole hydrochloric acid rated multiplied with half, we will get a 1.77919 multiplied with 10 negative 3 mole of calcium carbonate. Fifth step is find the mass of calcium carbonate. We can calculate this by using the mole of calcium carbonate, which is 1.77919 multiplied with 10 power of negative 3 mole multiplied with the molar mass of calcium carbonate, and we will get the mass of calcium carbonate is 0.1781 gram. Last step is the mass that we obtained on the previous step. We will divide it to 0.2 gram and then multiply with 100 to get the percentage. By the way, the 0.2 gram is the mass of eggshell. The percentage that we obtained in the brown eggshell is 89.05%. So next, I will continue to explain the calculation of the white egg. It's actually the same calculation that we do in the previous calculation, but with different data. The difference that we can see is on average volume of the sodium hydroxide used, which is 0.017846 liter. After we calculate, the final answer is 84.63%.
Comparison of percentage calcium carbonate in chicken eggshell and duck eggshell. As we can see in the graph, the average percentage of calcium carbonate is higher in the brown eggs, which is 89.5% when compared with white eggs, which is 84.63%. In conclusion, this experiment has successfully determined the percentage of calcium carbonate in eggshell using back titration. The excess hydrochloric acid reacted with the eggshell, and the unreacted acid was titrated with sodium hydroxide.
The difference allow for calculating for CaCO3 content. Back titration proved effective for analyzing partially soluble substances like eggshell, with results subject to minor errors from reaction or measurement inconsistencies.